Today I'd like to work through 4 examples, part 2 for arithmetic and geometric sequences. We're going to look at some of the same skills that we did in the previous lessons, but this time it's going to apply to 2 random terms. We're not going to be given the sequence in order, and we're not going to be given the first term. In this first example, they're asking us to find the common difference, the 52nd term, and the explicit formula. Just like we did before, we're going to find the common difference first. But this time, it's not quite as obvious. We're going to have to use 2 random terms and find that common difference. So I want to go over a little bit of what are the behaviors of an arithmetic sequence. Since an arithmetic sequence is adding the same term over and over to progress from term to term, it does have a linear pattern. That means that if we want to find that common difference, we can use slope in order to do that. So just to refresh your memory, the equation for slope is y2 minus y1 divided by x2 minus x1. Well, you might look at that and say, I don't see any x's and y's in what is given to me. So we got to talk about what is an x and what is a y. When we're talking about functions, the x is the input value and the y is the result, the output. So if you think about each of these individual terms in a sequence, the term number is actually what we input into the explicit formula to then get the output or the answer. So the number is the x and the answer is the y. I'm just going to call this one the x1 and y1 because it's the first term that comes in the sequence. This will be my x2 and my y2. So now, if I want to find the difference, I'm going to set it up like a slope problem. y2 minus y1 divided by x2 minus x1. You can use your calculator or you can do mental math to solve this. When you simplify it, you're going to find out that the common difference is 8. That means that if we want to progress forward in this particular arithmetic sequence, we would add 8. But if we want to go backwards in the sequence, we're going to subtract 8. So they've given me term number 13. In order to write an explicit formula, I need term number 1. So let's think about this. You could actually take 90, put it in your calculator, and subtract 8 over and over and over until you got back to term 1. So here's the question. How many times would you subtract 8 to get from term 13 back to term 1? If you answered 12, you're right. So let's just set up an algebraic equation for it. If I take the given number, 90, and I want to go backwards, I'm going to subtract the difference, which is 8, 12 times. If you put this into your calculator, you're going to find that term number 1 is -6. Now that you have your difference and you have your first term, now you can write your explicit rule. A sub n is equal to the first term plus the difference times n minus 1. They've asked me to find the 52nd term. So everywhere that I see an n, I'm going to put a 52. Once you simplify this problem, you're going to find out that the 52nd term is 402. All right, let's do this same type of problem one more time, just so you can see the process. Since an arithmetic sequence has a common difference and progresses the same way every single time, it does have a linear behavior. And therefore, to find the common difference, we can use the slope formula. The slope formula is y2 minus y1 over x2 minus x1. To identify your x and y, you need to think about your input versus your output. The x is the term that is being put into the explicit formula in order to get the output or the answer. So in each of these, the term number is the x and the answer is the y. Now let's set up our equation. My difference will be equal to the second y minus the first y divided by the second x minus the first x. Be really careful with these negative signs. Make sure that you have written down a double negative. When you simplify this, you're going to find out that the difference is -9. Now it's time to find our first term. Since I'm given term 12 and I need to go back to term number 1, I'm going to subtract the difference. So how many times will I subtract the difference? If you answered 11, you're correct. If you're starting at term 12 and you're going to term 1, if you'll subtract these term numbers, you'll know how many times you have to subtract the difference. So let's take the number that we're starting at, -71. We're going to subtract the difference, which is -9, 11 times. Once you simplify this, you'll find out that term number 1 is 28. Now it's time to write our explicit formula. A sub n is equal to the first term plus the difference times n minus 1. Since they want us to find the 52nd term, we'll put a 52 everywhere that we see an n. Once you simplify this, you're going to find out that the 52nd term is -431. Now that I've done 2 examples for arithmetic sequences, I would like to do 2 examples for geometric sequences. You can see they're asking us to find the common ratio. We're also going to write an explicit formula, and then we'll use that explicit formula to find the 8th term. I'm going to approach this a little bit differently because these numbers are closer together, and I'd like you to visualize what they've given us and what we're missing. They didn't give me the first term, but they did give me the second. They didn't give me term 3 or 4, but they did give me term 5. Here's one of the things you need to remember about a geometric sequence. If you are progressing forward in a geometric sequence, you're going to multiply by a common ratio. But if you're wanting to progress backwards, you're going to divide. So let's think about this. What am I multiplying by to progress 1, 2, 3 times forward in this sequence? Again, we're multiplying by a common ratio, so I'm going to put multiply by r 3 times. I can set up an equation for this. I'm going to take the number that I'm starting with, and if I multiply it times r 3 times, it would look like this. Now you and I both know we don't usually write our r out this way. We would combine these. When you're multiplying a variable, you add its exponents. So multiplying r 3 times would actually be written as -5r cubed. Now that you've simplified this, it's easy to see how to solve. If I want to solve for r, and it's multiplied by -5, I will start by dividing -5 on both sides. R cubed is equal to -125. Now, you're going to need to take the cube root of both sides. The cube root of -125 is -5. Now I have my r, I just need my first term. So, if you progress forward by multiplying, remember you can go backwards by dividing. So all we have to do is take the term that we know, and we're going to divide it by the ratio that we just found. -5 divided by -5 is +1. So my first term is +1. Now I can write an explicit formula. The explicit formula for a geometric sequence is the first term times the ratio raised to the n-1. You're going to fill in your first term and your r. So my explicit formula will be 1 times -5 raised to the n-1. I'm going to use my formula to find the 8th term by plugging an 8 in for each of my n's. Once I simplify it, I will find that the 8th term is -78,125. Let's do one final example. Again, we have a geometric sequence, and we want to remember that if we are progressing forward, we multiply, but if we need to go backwards, we will divide. In order to start this process, we do need to find the common ratio. Just like I did last time, I'd like you to visualize what you have and what you're missing. You do not have the first or second terms, but they did give you term number 3. You're missing terms 4 and 5, and they gave you term number 6. To set up an equation, I need to know how many times I will go forward to get from one term to the other. I'm going to need to multiply by r 3 times. So if I don't have a visual, is there a way I could look at it over here and determine how many times I'll be moving forward? Yes, just look at your term numbers. To move from 3 to 6, I'll have to progress 3 spaces. You can do that through subtraction. Remember, however many times you multiply, it will be written as your exponent. So we've got 48 times the ratio 3 times. And that's going to be equal to -3,072. To solve, since these two terms are multiplied, I'll divide both sides by 48. R cubed is equal to -64. Again, to get rid of something that is cubed, I'll take the cube root of both sides. So r is equal to -4. Now that I have my ratio, I know how to go forward, and I also know how to go back. I need to get to term number 1. So, in order to move backwards, I divide by the ratio. So if I divide 48 by -4, I get -12. But I got to go back one more time. If I divide -12 by -4, I'm going to get +3. Now I can write my explicit formula. A sub n is equal to the first term times the r raised to the n-1 power. I'll find my 8th term by plugging in an 8 everywhere that I see an n. Once I simplify, I find out that my final answer is negative 49,152.